the second law of thermodynamics. Second law of thermodynamics can be stated in many ways. It is impossible to construct an engine which operated in a complete cycle will absorb heat from a single body and convert it completely to work without leaving some energy or changes in the working system. This is called as the Kelvin-Planck statement of second law of thermodynamics. You are able to see the heat is generated in one area. It is not completely moved without changing the area of this one. If heat is generated, automatically this zone will be getting heated. So it's changing the system, right? That's referred to as second law of thermodynamics. Point 2 is, it is impossible to transfer heat from a cold body to a hot body by a machine without doing some work. This is called as the Clausius statement of second law of thermodynamics. From here, the heat cannot be transferred to here without doing any transformation. The third point is, a process accomplished by increase in entropy tends to be spontaneous. This statement is called as the entropy statement of a second law of thermodynamics. Entropy is a measure of randomness of disorder of the molecules of a system, and it is thermodynamic state function. A system always spontaneously changes from order to a disordered state. Therefore, entropy of a spontaneous process is continuously increasing. So, the efficiency of a machine is never be 100%. It can't be 100%. The heat efficiency of a machine is given by the value of ratio of output to input engines and energies. The output can be in the form of any measurable energy or temperature change, while input can be in the form of heat energy or fuel amount, which can be converted into heat energy. Let's move on to the percentage efficiency, which is calculated as output divided by input into 100. The machine can be a heat engine also. Consider a heat engine which has the initial temperature of T1 and final temperature as T2. Then if T1 greater than T2, then when some amount of energy or heat is being converted into work, T2 is the lower temperature. The efficiency nu, this is called nu, is given by, it's called eta. So eta. The percentage efficiency is given by T1 minus T2 divided by T1 into 100. T1 is the initial temperature, T2 is the final temperature. The percentage efficiency can be never be achieved as 10% as per the second law of thermodynamics. So percentage of efficiency is given by 1 minus T2 by T1 into 100. So by second law, T2 is lesser than T1%, the efficiency less than 100. So according to the second law of thermodynamics, it is impossible to have a machine or heat engine which converts the input energy completely into output energy without any amount of heat or energy being absorbed by the machine, as referred to as second law of thermodynamics.